So let's just highlight our numbers here. We have an average mass, average distance, and average time. And now we're going to have to put them into this formula for kinetic energy. Now, we need to actually sub everything in here. Now, notice we've got distance and time, but we're trying to find velocity. The velocity of your object, or your car in this case, is equal to its distance divided by its time. So if I take my distance and time over here, then that will actually calculate the velocity for me. But I'm just going to put it into our equation here because we've been using algebra in our math and should know by now how to actually put it in. So when I go a half mv squared, instead of velocity, I can calculate that using distance and time. Half of my mass times my distance over time, and I'll have to put brackets around that, squared. And that's how I work out my kinetic energy. Now you guys have all learned from your algebra that bid mass tells us that we need to do our brackets first, then our powers, and then all of our multiplication and dividing and plussing and minusing in that order. So I'm going to fill this equation in and work it out. 0.5, that's my half, times by my mass. Write it in as a kilogram. That's where the numbers get a little bit confusing. 0.002 kilos times by my distance over time, 0.228 meters over 2.84 seconds. They have to be done first, and then we square it. And then you just put this into the calculator. It looks confusing to begin with, but all we've done is found our mass, our distance, and our time, and we've put them into this little equation here. So I'm going to get this and divide it, then square it. This number here becomes 0.080, and I'm going to have to square it, and I'm left with 0.0064. That's me squaring it. And I have to multiply that by 0.5 and 0.002. Now, here's the long little number that you get at the end here. And it looks like it's very small. Well, yes it is, because we had a very little car. But so the energy to actually move it is actually going to be quite small. And the units that it's in is called joules. That's the actual unit of energy. Now it's really, really quite small, we know that, but that's because it's a small car. That is step by step how you go from your numbers here to averaging them, to converting them into kilograms and meters and seconds, putting them into your equation and figuring out how many joules of kinetic energy your car had before it stopped. That is the answer that we put in up here. My kinetic energy of my car was, let me go down here and see it. How many zeros? 1, 2, 3, 4, 5. 0.000064 joules of energy. Now what you're going to be doing is you're going to be learning a little bit more about how to change the amount of energy your car receives, how to make sure that you're not wasting energy so you can build a better machine and beat that number. We want to have a car that has a lot more energy than that using your next design.